This is video number 6 of 7 using the Big M Instructional Guide for Florida to go over practice problems that were provided by the Florida Department of Education. So these are the standards we'll be covering in this video, and let's get into it. So the first question right here, it has a circle and it has two intersecting segments in this circle. It says FE, which is this segment right here, is 1.3, BF is 1.9, FD, which is this part right here, is x plus 1.3, and then CF is x. Now in this diagram, how it works is this times this equals this segment times this segment. So that is how we are going to set up this problem. 1.9 times x, so 1.9x equals 1.3 times x plus 1.3. And for this one, I'm going to distribute this by multiplying 1.3x plus, and 1.3 times 1.3 is 1.69. We will solve for x here. And we get this number here, 2.816 repeating, round to the nearest tenth. So just 2.8 is our answer for the value of x. Okay, on to the next question. The International Space Station passes over the Earth 248 miles above the Earth's surface. The angle formed between the two tangents formed and the Earth measures 140.4. What is the measure of the arc of the Earth that could have a view of the ISS passing overhead? Okay, so for this one, the center of the Earth right here, if we connected these lines, the radiuses, to the tangent, it should make a 90-degree angle. Therefore, we have a quadrilateral, and the opposite angles in this quadrilateral are supplementary. You could determine that because the angles of a quadrilateral add to 360, so you could do 360 minus 90 minus 90 minus 140.4. Or in an inscribed quadrilateral like this, the opposite angles are supplementary. So 180 minus 140.4 will give you the answer here. 180 minus 140.4 is 39.6, and that is our answer here. 39.6 degrees is this angle, and that would also be the angle of the arc right here. Okay. And then if you needed to find the measure of the arc, you could use this. I don't know if it's asking for the angle measure. The answer key said this though, so we'll leave it at that. Okay, next one. In circle A, segment DE is the diameter. So here is our diameter. Determine the measure of angle C. So we're trying to find this measure here. With an inscribed quadrilateral, the opposite angles are supplementary. So to find angle C, we do 180 minus 73, 107 degrees, and that would be the measure of angle C, so 107 degrees. Then measure of angle D is what it's asking for next. So this angle right here. Now this is a bit of a jump if the measure of arc CF is 50. So this arc is 50 degrees. Okay, so we have an inscribed angle right here. We can take the measure of this arc, divide it by 2 to get this inscribed angle. So what we're going to do is we're actually going to use this inscribed angle, multiply it by 2 to find this arc here. So 73 times 2 would be 146, and that's all the way over here. Then this is a diameter, so all the way around to E would be 180. So 180 minus 146 would give us 34, and that's this part. So now 50 plus 34 would be 84 degrees, and we can divide that by 2 to get this angle. So this would be 42 degrees. So that angle, 42 degrees for D, and then with the quadrilateral, opposite angles are supplementary. So for this last angle F, we can do 180 minus 42 to find that one, and it would be 138 degrees. Okay, next problem. this one here, it has this as a diameter. When you have an inscribed triangle with the diameter, the hypotenuse is the diameter right here, makes a right triangle. So determine the value of x if the measure of angle E is 2x plus 30. Well, we can set that equal to 90 and solve for x. X equals 30. Okay, find the measure of angle D next. It tells us that angle A right here is 2x minus 20. Well, we can plug in x equals 30. So 2 times 30 minus 20 would be 60 minus 20, which is 40 degrees. So this angle is 40 degrees, but it's asking for angle D. So if all these angles add to 180, 180 minus 90 degrees minus 40 degrees equals 50 degrees for angle D. Okay, next problem. This one, it wants us to find the area of this sector here. Okay, has a diameter of 23 feet. The stained glass design is equally spaced about the center of the circle. What is the area of this sector? Okay, so area of a sector is like part over whole equals area of the sector of sector over area of the circle. Part over whole, a lot of times it's degrees over 360. In this case, I can see like 2 parts of the stained glass mural, and I'll just count how many parts there are all the way around. So it'll be 2 over however many there are around. So 1, 2, and then if I was to count all the way around, 3, 4, 5, 6, there's 32 of them. So 2 out of 32 parts. The area of the sector X, area of the whole circle, well, area equals pi r squared. Diameter is 23, so radius would be 11.5. So I got pi 11.5 squared. We'll go right here. And then I can use cross multiplication to solve for the area of the sector. So I get 32x equals, multiply these two numbers, and it comes out to 830.95, and we'll divide by 32. X equals 25.967. I look at how they want me to round it to the nearest hundredth right here. So 25.97 square feet is my answer. Next problem. Equation of a circle. Given the equation, determine possible values of E such that the equation is an equation of a circle. Okay, so here we need to get it into the other format to see what E is. So what I'm going to do is I'm going to group the X's together and the Y's together. They already did that. I'm going to complete the square, and then I'll put E on the other side, negative E. Okay, so solving for these blanks, I take this term, divide it by 2, I get 1, and then I square that, so this would be 1, and whatever I add on this side, I have to add over here. Take this middle term, negative 4, divided by 2, square it, I get 4. Whatever I add over here, I also add over here. And now looking at this, now it wants to know what the value of E is. Well, E, as you know, is the radius squared. It can't be 0, because otherwise you wouldn't even have a circle, you just have a center, right? And it can't be negative, because distance is always at positive. So E has to be less than 5 for it to even make a circle. So 1 plus 4 is 5. E has to be less than 5 for this to be a positive number, which makes a circle. Okay, the next one, what is the equation of a circle centered at this and a diameter of 2? This one is much easier. X minus negative 1. This would be 2. Remember, the equation of a circle is x minus h squared plus y minus k squared equals the radius squared, with hk being the center. Be careful with the negatives. This one kept a negative right here, so that's why I'm putting in like that. And then the radius squared, well, diameter is 2, so radius would be 1. So 1 squared would equal 1. So I'll put 1 right there. Next one, what is the equation of a circle centered at this and passing through 5, 0? So centered at -2, -5, passing through 5, 0. So the radius of this circle is going to be the distance between these 2 points. So the center, I can just plug that right in. -2 would go here, -5 here. But for the radius, I do need to find the distance between those 2 points. Distance formula, x2 minus x1 squared plus y2 minus y1 squared, the distance. Let's see, so 5 minus -2 squared plus 0 minus -5 squared, 7 squared plus 5 squared, 49 plus 25. 74. Okay, I got square root of 74 for the radius. And as you know, this is radius squared. So square root of 74 squared would just be 74. So that's why this would be 74. Okay, next problem. Another one on equation of a circle. I'm going to zoom out because, okay, on this one, it has a map. It says a florist serving Orlando area is located at 9-8, and I know it's a little blurry, but this X is at coordinates 9, 8. The florist has a 50-mile delivery radius. Let's see, and each unit is 10 miles, so 50 miles would be 5 units out. 2, 3, 4, 5, and then it would make like a circle, 5 segments there. Okay, so write an equation that describes the delivery area. It would be x minus the x coordinate, y minus the y coordinate, and then it would be radius squared, which 5 units would make the radius. So 5 squared would equal 25. So blank 1 would be 9, 8, and 25. Next one. Equation of a circle. We have to change the format here. It wants to know the center of the circle, the radius, and the maximum y value. Okay, so let's zoom in again. So the steps for how to change this are to 1, group it. We're going to put the x's with the x, y's with y's. Then we are going to complete the squares. We're going to then factor. And then the last step is to just reformat it so we can pull out the center and the radius. Okay, so first group it, we're putting x's with x's, x squared minus 6x plus blank, y squared plus 8y plus blank equals, and then we'll put the 5 on the other side of this. And then we need to find out what goes in the blanks. So we take this term divided by 2 and square it. We get 9, so we add that to both sides. And then the 8 divided by 2 and square it, we get 16. Add that to both sides. Okay, and now we need to factor it. This would be x minus 3, y plus 4, y plus 4. So x minus 3 squared plus y plus 4 squared equals, so be 25 minus 5 would be 20. Okay, so now that it's in this format, I can get the center. The center would be at positive 3, negative 4. And then the radius would be square root of 20. So let's see, the center of the circle occurs at 3, negative 4. The radius round to the nearest hundredth if necessary. So in the calculator, I'm going to take the square root of 20, 4.47. And then maximum y value of the circle occurs at what point? Okay, circle, center, 3, negative 4. Maximum y value would be straight up. The x would stay the same. And the radius is 4.47. So let's just add that to the y value and we get 0.47 here. So you get 3.47. Okay, and that is all for this video here. And I will have video number 7 linked below. Video number 7 linked below. See you there.